Alright, so this video is to help you with the Handwarmer Design Challenge Lab. Just to review with you, with this lab, you did this over the 2-week period where you researched the solids and developed your procedure to determine which solid would be the most effective hand warmer of the 3 that you were given to choose from. And then you actually conducted the experiment in week 2 so that you would have your data to be able to answer the questions that came up. Note that in the procedure you were asked to make notes about the safety concerns, precautions, disposal guidelines, record the enthalpy solution values, rank the solids you were given from least to most expensive, and then develop your procedure and data table. I don't need your procedures specifically in your lab notebooks. You can put them in there if you would like, but you definitely need to have the other information that was listed here, and it says that up here at the very before step 1 of the procedure. You want to make sure that you write down the solids, the material safety guidelines, the enthalpy solutions, rank them, and then have your data tables in there. I've already seen your procedures, which is why I'm not requiring you to include them in the lab notebook. You can, however, if you wish. So for your calculations, you do need to show sample calculations with your sig fig and rounding rules included. Make sure you follow appropriate units or include appropriate units. So the questions I'm going to focus on are the first 4, and then the last one. Question 1, I felt like when I went back read over it, it wasn't super clear, so I want to make sure that you understand why I'm having you do this. It says dissolving ionic solids involves separation of the solid ionic compound into cations and anions in water. It can be represented by an equation showing the solid as a reactant and the aqueous ions as products, and you can calculate the heat of solution for that reaction, which is kind of the goal of this experiment. So what I'd like you to do for question 1 is to write equations for your 3 solids showing them dissociate. I've given you an example. Sorry, I should have K through PO4 be a solid. Because you started with solids and then you added them in the presence of water, and that caused them to dissociate into their ions. Because there were 3 potassiums, potassium phosphate, you see the 3 coefficient in front of potassium ions on the product side of the equation. Step 2, or question 2, asks you to calculate the amount of heat released or absorbed by the water. And that's where you get to use your temperature changes, your mass, your CP, and your delta T. CP of water is still 4.18 joules per grams degrees Celsius. I believe you should have measured temperature changes. At least I don't remember reviewing any labs where you did not measure an initial and a final temperature of the water. And then you should be able to determine the mass based on how much of the solid you added. And you may assume the density of water is 0.998. So if you added, say, 50 mils of water, you'd multiply that by the density to get the mass of water that you added. I would definitely include with the mass of the solid that you added, because that too would have been part of your mixture, and that's basically what we're using the water to determine. And number 3, calculate the amount of heat released or absorbed by the solid in joules. Just remember the Q's should be opposite. One absorbing heat is getting that heat because something is releasing it, or vice versa. So if you know the Q of the water, to get the Q of the solid, you just want to take the opposite of that value. And number 4, you're asked to calculate the delta H of solution. Notice it says kilojoules, so make sure you change your joules from number 3 into kilojoules. And then you need to include the moles of the solid, so you know how much of each solid you use. You want to convert those to moles and divide that by the Q to get your delta H of solution. Number 5 asks you to calculate percent error. You actually already have the accepted values. You did that in your research. Number 4 gives you the experimental. Make sure you round it to 0.1%. And so you'll do that for each of the 3 solids. And then it says, what are sources of error? Sources is as plural, and then it tells you after that to identify 2 of them and tell me the effect. If all you do is tell me the 2 errors and you don't explain the effect of them, you will not get full credit for this question. Same if you only do 1 error. Number 7, the dissolving processes for each ionic solid, endo, exo, or neither. So based on the data that you collected, would you expect the solids to be endothermic? Would they absorb heat in order to go to that change? Would they release heat, be exothermic, or did they not change at all? Number 8, changes in matter are generally classified as physical or chemical based on whether new substances are formed. Does dissolving represent a physical change, a chemical change, or an intermediate change? And explain your reasoning. So again, looking at the equations that you wrote in question 1, did you make something new? Because that's basically the hallmark of a chemical change. Did something get transformed, or did it just change from the form it was in before to a different form. Say a solid gets added to water, or excuse me, if the water gets taken away from a solid, it's still the same solid, you've just removed the water from it. So kind of keep that in mind. Chemical changes are going to make something new. Maybe an ion will become part of a different compound, or it will go back to being an element, or vice versa. Number 9, based on the cost information provided as well as your experimental results, select the ionic solid that would be the most cost-effective hand warmer. So again, you've got your cost data, and based on your data, which one gives you the best bang for your buck. Number 10, based on that information in number 9, calculate how much of the ionic solid you would need for a hand warmer to increase by 20 degrees. So you know the Q of your solids based on what you calculated back in number 3, but you would know that just for the amount of solid that you used. We don't know how much solid you're going to want to use for this one, so you may want to use the delta H value for number 4 to help you determine this. You're going to want to use your MCP delta T equation, and you have your temperature change. We don't know the CPs of our solids, but we know the CPs of water. So if you want to go in the opposite direction, remember that you're going to want to account for that with a sign of your Q value. So hopefully that will help you with this lab, and if you have any other questions, please feel free to ask.